Hello everyone. So I'm Irena from the Yahoo research in Haifa office. I'm a senior research engineer, and today I will talk about automated extractions for machine-generated mail. Actually, this talk is based on a paper that was recently accepted to the web conference, and I presented it last week in Lyon. And it is a follow-up to the previous use case I described of classification. And it's a joint work with the researchers from Yahoo and also production, mail product team. And I will start with a short intro. Okay, so in Yahoo research, we do big data analytics. So what are the big data sources in the world? We have obvious images and videos, but also mail. In Yahoo Mail, you have around 225 million monthly active users, and it's a large scale. But why we focus on machine-generated mail in our projects? Mainly because it's more than 95% of your inbox. Let's define what I mean when I say a machine-generated message. It's a message that was generated by a script, by a machine, and not written by a human being. For example, order confirmation, travel itinerary, coupons, marketing, and so on. What is so special about this traffic? First of all, it's highly structured. It's a script and not a person who typing a message. And it repeats at large scale. No one will write a script to generate 10 messages. It will be repeated many, many times for different users, the same script, and yet it is very important and personal data. It's used in a lot of features that helps user, also for marketing. And the nature of this traffic, the fact that it's repeated large scale and very structured, helps us apply learning techniques and extractions. So now I will give you some motivation why it's important to do extraction and mainly automate it. Many of the latest Yahoo features in Yahoo Mail based on extractions. For example, here you have the feature of clipping coupons. Coupon extracted, and you can save for later coupons that you are interested in and receive notifications when a coupon expired, or travel alerts. Also, you have latest shopping experience. It's a deal with Ernie that enables you to save money. We extract the purchase and the price, and for each product, using Ernie, we are able to find if there is the same product for a lower price, the user can receive money back. So all those features are based on extractions from machine-generated messages. And the high amount of domains and use cases and structures force us to do it automatically, of course, and not manually. So what is information extraction? Let's go by an example of Ariel, my team member, his flight confirmation. So we want to extract data pieces of information from his message, and for each text, for each data, we want to associate it with a label, contextual label. For example, here the flight number is UA954. We have also the departure place, San Francisco. We have the TLV string, arrival airport, and so on. So this is a task we want to solve, to extract the data pieces and annotate them. And the background, also the same. I use the same cluster type I used in previous lecture, is actually called X cluster. We use it here because this is the input for our method. And this was suggested by my team 2 years ago. And let's follow an example how we do the clustering. Given this simple HTML message, we want to get this signature to represent the cluster this message belongs to. How we do it? We said that we will look on the structure, not the content, not the values themselves. So in order to know what is the structure of HTML, we will look on the DOM tree, the HTML tags. After we are building this tree, we will do in-order traversal and generate list of XPaths. Actually, XPath is a concatenation of HTML tags. And it's also important to do it in the same order. The order of the XPaths is also important. It will affect the signature we receive. We are looking only on textual leaves. And applying this mail hash signature that is linear and very efficient. Obviously, it must be because we need something that is scalable for the big data we work with. We receive this signature. So after I remind you what is X cluster for those who heard the previous lecture. Let's see how the mail extraction process goes. So our process consists of two parts, offline and online. The offline part is the key of the work. Actually, at the offline part, we generate the extraction rule that later we will apply on a new message that associated with the same X cluster, and then we will be able to know what are the extraction values online. How the offline process goes, we need to collect a sample of messages for each X cluster. And for this X cluster, actually the input is X cluster table. I will explain what is this data structure we use. This is the input, and we have two phases to create the rules. We create a basic rule and then refine it with contextual annotations. Okay, so given we received this sample of messages from a specific X cluster with AA domain, and this is the extraction table. In this table, each row represents a message in a sample, and each column belongs to XPath. Why all the messages in this sample aligned? Why all of them has exactly the same columns? Because they belong to the same X cluster. It is a definition of the X cluster. So important part, so we start with sampling and creating this extraction table, but before we go to the rules generation, we also differentiate between constant and variable XPaths. In this example, the third XPath is considered constant. It has exactly the same values for all the samples, like a header title, for example. It's not interesting to extract it the same for all the users. It's not something personal. And the first and the second XPaths are variable. They contain information that is different from one sample to another. That is why we will want to generate extraction rule for XPath 1 and extraction rule for XPath 2. So let's see what are the steps to create the rule. As I said before, two steps, basic rule and refined rule. Let's look again by an example. We have this value for our XPath, departing at 9 a.m. First, we are cleansing the constant part in this value. We are removing the departing at because the value we want to extract is 9 a.m. And we also associate it with light annotation time. Also, this is the first step. This is a basic rule. In the refined rule, we will replace the time annotation by a contextual annotation. For this example, it will be departing time because we are talking about flight. So what annotations we use? Oh, it's not look very nice. So we have two types of annotators, dictionary and format patterns. But the most important part in annotators, if you can see, is that we need only a defined percentage of the samples to be inside this dictionary or to match the pattern. For example, in this table, you can see that the second string after hello is a name. But for my dictionary, for each annotation, I created a separate dictionary. For example, for names, I have a list of names, but I'm not able to create a dictionary of all the names in the world. It's not feasible. It will also take a very long time to check if it's inside the dictionary or not. So I will take the most popular names, and I need only, let's say, 70% of the samples to have the second word in the dictionary. Here, Jeff, Ron, Marissa, Francois, Liane are in the dictionary, so the fact that Ira, Dotan, and Nick are not part of the dictionary, we are still able to annotate the second string as a name. The same goes for the patterns. So for the dictionaries, we use it for names, airport codes, places, and for the second type of annotator, it was like URLs, emails, that you have a regex to represent this structure, currency, numbers, times, dates, and so on. So after we understand what are the light annotations, it can be used in different use cases for travel, for purchase. It doesn't matter where this date appears. We will see how the rule will look like. So given that those are the 5 out of 50 values for specific XPaths in one of the X clusters in United Domain, this is the basic rule I want to generate. The extraction rule represented by regex. The constant part of the regex, the check-in is open for, actually is the part we want to clean, we want to remove. And each wildcard represents the data we want to extract, when each wildcard associated with light annotation. In this example, we are removing the check-in is open for prefix from all the values we receive. Then we take the string and label it as flight number. Then we have comma departing from, and next value we'll extract is associated with light annotation place, and so on. This is our basic rule. Now we go to the second phase of rule refinement. Now we want to give a context. We will look not for specific column in our table, not specific XPaths. We will look on all the message in order to understand the context. And obviously, it's important what use case we are working with, because the context annotation we will replace are different in different use cases. For example, here we will replace for flights date to date depart, date arrive, date booking. If we are talking about purchase, we will replace the date by date purchase date, or if it's delivery, when it will deliver. And our approach to do so, how we know to what the context label to replace, is by classification. As I said before, we are looking on all the X cluster on full message, and now we do consider the constant XPaths that we ignored before, because they contain a lot of indicating words that can help us through the classification step. So let's talk more about the classification part. We train a model for each light annotation to when the labels are the contextual annotations that we want to replace to. For example, for date, we saw that we will have 3 labels, optional labels, like dates that can be replaced to date booking, date depart, and date arrive. We will have features for each light annotation inside the XPath. The different features we used are, for example, relative XPath position. Why it's important? Because the booking date usually appears on the top of the message, and we want our classifier to be able to learn it. Also, annotations before and after. If currently I never saw date before, current date cannot be date depart because, date arrive, because you need to see the date depart before the date arrives. So it's one of the features, what annotations you saw before, what annotations you saw after the current light annotation. The constant values, the HTML headers, they all contain indicating words like departs, arriving, and so on. So we trained our classifier, and for each light annotation we are able to replace. Here I have some examples of how it will look inside the message. So here the constant values can appear inside the table as a header or just textual. So we are looking on the XPath before, and this XPath is a constant, but we are taking it into consideration in the refinement step. Okay, so now we know how to generate the extraction rule, and we received a new message, and the XPath value is as follows. And the extraction rule is like we built before, but now we replaced by contextual annotations. And the output, the extractions we will receive for this new value that we got are like New York, associated with play depart, BCN with airport arrive, and all those values are extracted from this XPath using the extraction rule we just generated. Any questions before we go to the evaluation?
Do you deal with multi-languages or just English?
Yes. Actually, it's not dependent on a language, maybe only the light annotations, but we can create a dictionary. Actually, we deal it by creating multiple rules for each XPath. So if in a sample you will have 70% English and 30% in French, you can have hello name and bonjour name. And then we will try, given a new value, we will try to match. If you receive the message in English, it will match the second rule that starts with bonjour. If it's the English, it will match hello. So it should handle a multi-language, but it depends on the sample you receive. If it's very rare, and we usually sample for a week or two, it depends. So if you never saw it, so you will not be able to generate the rule. So some statistics about the travel domain, just for you to understand how the X clusters behave. Here we sorted the domains by the number of X clusters. It's a blue curve, and obviously it's exponentially descending. And the red curve actually represents the traffic ratio. When I talk about traffic, I mean what is the amount, what is the percentage of travel messages that this domain contained out of all the messages that were classified as travel. Actually, we classify the clusters, and if the message belonged to a cluster that was classified as travel, it's considered to be a travel message. So you can see there is no correlation. You can have up to 60 clusters, X clusters, but your traffic will not be the top, not the highest percentage of messages. Here we just show the top flight domains versus the X clusters number, and you can see that this method should be able to handle domains that has a lot of structures that tend to change frequently. And you have messages with a little low amount of X clusters. Maybe they're really big, and then you have to maintain less rules. But here we suggest automatic message. So you see that manually it will be really hard to maintain it because it's not feasible. We will talk a little bit more about this fact because, as I said, I need minimal amount of sample in order to generate a rule. So I filter X clusters that don't have enough samples, and I don't want to lose a lot of coverage. I will go to that at the end of my evaluation. So let's just show what are the evaluation results. Yeah, 5 minutes. Okay. We work with precision recall, and we looked based on a manually labeled set of 850 X clusters that covered 6 travel domains. Obviously, the labeling was done under full privacy preservation according to Yahoo privacy policy. And we see that the first step, the basic rule, is reach very high precision recall results. Most of them are above 90%. We see that in recall we could improve, and mainly, given the examples we saw, it's by increasing the dictionary. It's easily by adding more values to the dictionary, we will increase our recall. And the refined extractions, the second step, now I want to know what is my classifier precision. Given my light annotation is correct, do I replace to the correct contextual annotation? And here again, the results, we reached really high results. All the precision values are above 90%. We saw that also the recall is high. I saw that date booking, we were a little bit lower. Checking the label set, we saw that it appeared really small amount of times. Most of the X cluster didn't have booking date, and maybe probably taking a larger label set will improve these results. At last, we looked on end-to-end evaluation. We compared with manual extraction, given the current extraction we have in Yahoo. We evaluated 10 million messages that associated with 36,000 X clusters. It's important to note that in test we had 100 domains, and only 40 intersect with the domains we had in our labeling set. So we obviously evaluated the new domains that we didn't tested our classifiers on. And again, we saw that it yielded really high results, more than 90% in precision and recall, and extraction use case focused on precision. This is more important for us because we are using facing features, and the precision here is high enough in order to be able to show the users the extraction values. And last, as I promised, to speak about the sample size. This parameter, we call it gamma, and it's a trade-off. If we take really large X clusters, really large samples, obviously our quality will be higher. And here we see that we need only about 20. We used 50 samples to reach high enough that adding more samples didn't improve. And if we look only on large X clusters, we will lose. We filter small X clusters. But even though taking larger than 20 samples decreased about 90% of the X clusters we took, still we see that the coverage, the amount of messages, the amount of domains remains up to 85%. And we are caring about the coverage, how many messages we extract from, and not the X clusters. So it's good enough for us. And I think the conclusions. So I showed the fully automated extraction method for machine-generated messages. And we relied on the X cluster. Our basic goal in dealing with machine-generated messages is usually to group together messages that were generated by the same script, and then to learn and apply different techniques. We conducted large-scale experiments and showed good results on the classifier and also for the large-scale experiments. And this system productized in Yahoo Mail backend. So, and was accepted to WWW conference this year. Thank you. Yeah.
Can you talk a little bit about the machine learning models that you used for training?
We tested several. I think we finally we selected the random forest to be used, but it's known techniques. It's like a vector of features that I showed before, and the random forest is the algorithm we selected for the classification. Thank you.